For billions of years, the Sun has dominated our corner of the galaxy. Its immense gravity holds the planets in orbit. Its energy fuels life on Earth and shapes the environment of the entire solar system. Every second, streams of charged particles race outward from its surface, creating a vast region of influence that stretches far beyond the outer planets. For most of human history, this seemed like a system governed by predictable laws. The Sun produced its solar wind. The planets followed their paths. Space between them appeared empty and quiet. But modern instruments have revealed a far more dynamic reality. Earlier this year, researchers analyzing observations from multiple solar missions identified unusual variations within the flow of charged particles moving away from the Sun. At first, the changes appeared insignificant, small distortions hidden within enormous amounts of data. Yet the deeper scientists looked, the more intriguing the patterns became. The solar wind is rarely perfectly smooth. Magnetic fields twist through it. Solar eruptions create turbulence. Powerful storms can send shockwaves racing across the solar system. However, these disturbances seem different. Rather than appearing completely random, certain structures showed an unexpected level of organization. The variations repeated over time and appeared connected to a newly discovered visitor passing through our cosmic neighborhood. That visitor was known as 3I Atlas. As only the third confirmed interstellar object ever detected moving through the solar system, it immediately attracted global attention. Unlike ordinary asteroids or comets that formed around our Sun, this object originated in another stellar system entirely. It had spent untold ages wandering between the stars before briefly entering our region of space. Initially, astronomers believed it would be similar to previous interstellar visitors, a frozen remnant from a distant planetary system carrying clues about another star's history. But as observations accumulated, questions began to emerge. The object's brightness appeared to vary in unusual ways. While many natural bodies display fluctuations due to rotation and surface features, some researchers noted patterns that seemed surprisingly regular. Telescopes around the world turned their attention toward the mysterious traveler. Space observatories monitored its movement. Spectrographs analyzed the light reflecting from its surface. Scientists attempted to determine its composition, shape, and origin. Every new measurement added another piece to the puzzle. Meanwhile, solar observatories continued recording subtle changes within the solar wind. Whether these changes were directly related to the object's passage remained uncertain, but the timing was enough to spark intense scientific debate. Could an interstellar object influence its surrounding environment in ways not yet fully understood? Or were researchers witnessing a coincidence created by the natural complexity of the Sun itself? The questions multiplied. Computer simulations explored a variety of explanations. Some suggested interactions between charged particles released by the object and the Sun's magnetic field. Others proposed that unusual material compositions might create effects not commonly observed among ordinary comets. None of the early models provided complete answers. As attention grew, more imaginative theories emerged. remained compelling. The true significance of 3I, ATLAS may not lie in proving exotic theories, but in highlighting how little humanity knows about the vast region between the stars. Interstellar space is not merely empty darkness. It contains clouds of gas, magnetic fields, dust particles, radiation, and the remnants of ancient stellar events. Objects traveling through this environment for millions, or even billions, of years may carry information about places humans have never seen. Each interstellar visitor acts as a messenger from another part of the galaxy. Long before telescopes detected 3I, Atlas, it was already traveling through regions beyond our reach, preserving a record of conditions around a distant star. Its arrival offers a rare opportunity to study material formed in an entirely different cosmic environment. And that alone makes it extraordinary. As observations continue, researchers hope to determine more about its composition, trajectory, and history. Future discoveries may reveal whether its unusual characteristics are truly unique or simply part of a broader population of interstellar objects waiting to be discovered. What remains certain is that the universe continues to surprise us. Every time humanity develops a more powerful instrument, the cosmos reveals new mysteries. Every time we believe we understand our place in space, a new discovery reminds us how much remains unexplored. Perhaps the greatest lesson of 3I, Atlas is not that it answers a question, but that it asks one. How many other travelers are crossing the galaxy at this very moment? How many have passed through our solar system unnoticed? And what stories might they carry from distant stars?